Now let's take a look in this example. You can pause this video and try to answer the question. The process on evaluating this integral is to rewrite our function into its equivalent form, that is integral of 1 over cosine 2x plus sine 2x all over cosine 2x dx. And we can rewrite our first term here. This is equivalent secant 2x dx plus this is also equivalent to the integral of tan 2x dx. Now, if we can evaluate each term according to its equivalent integral, where the integral of secant 2x is ln secant x plus tan x. Now notice that there is 2x here, and if we use the chain rule of integration, then taking the reciprocal of the derivative of 2x, which is 1/2, then we can say that this is 1/2 ln secant x plus tan x. The integral of tangent 2x is the negative natural logarithmic of cosine 2x plus c. Rewriting our answer, this is also equivalent to 1/2 ln secant x plus tan x minus 1/2 ln cosine 2x plus c. Now that is our answer. Now if you are doubt with your final answer, you can always check it by differentiation, and if we arrive into this format, then we can say that our final answer is correct. But I will not show you here since I've already proven that the integral of secant is the natural logarithmic of secant x plus tan x on the previous video, so check it out. Now there's another method on showing our solution here, where the integral of 1 plus sine 2x all over cosine 2x dx is equivalent to the integral of secant 2x. And if you would not like to change the sine 2x over cosine 2x to its equivalent trigonometric identity, you can use this as it is, and then we will use the substitution method on arriving our final answer. Now, if we mentally solve this, we can assign that our variable u here is cosine 2x. Now, if we take the derivative of cosine 2x is negative 2 sine 2x dx, right? And all over cosine 2x. And using the neutralizing factor, we should have this one here, the negative 1/2, to neutralize our inside integral. Now this is equal to, this one will become 1/2 ln secant 2x plus tan x, and this one is negative 1/2 integral of the derivative of cosine 2x all over cosine 2x. Remember that cosine 2x here is not equal. Since we have a differential operator here, that means that we should need to take the derivative of cosine 2x here. So this is similarly equal if we use the substitution method and we write our solution, that is u is equivalent to cosine 2x, and taking the derivative of u is du is equivalent to negative 2 sine 2x dx, and this is our du. Then we could write this one as du all over the derivative of cosine 2x. So we can write this one as, in this term we have the negative 1/2 integral of du all over u. So this is also okay to write in this kind of solution. So let's continue. So this will become 1/2 ln secant 2x plus tan 2x minus 1/2 the integral of du over u is simply natural logarithmic. This is natural logarithmic of cosine 2x plus c. So this is also okay to show this kind of format of your solution. Now, on our next example, you can pause this video and answer the question. Now, there are three methods of showing our solution here. First, we should simplify our given integral into this format, in which this is also equal if we take out the cosine squared x cosine x. So this is true since cosine squared cosine x is cosine cube x. So this is true, all over 1 minus sine x dx. Now, using the trigonometric identity, which we have cosine squared x is equivalent to 1 minus sine squared x, and notice that this is a perfect square in which it has a factor of 1 minus sine x multiplied by 1 plus sine x. Simplifying our equation, we have the integral of 1 minus sine x 1 plus sine x multiplied by cosine x dx all over 1 minus sine x. We could cancel out 1 minus sine x here. Simplifying, we could get the integral of cosine x plus cosine x sine x dx. Now, the equivalent integral of this is to distribute the given integral on each term. Then the integral of cosine x is sine x plus using the substitution method. Now, if we let u is equivalent to sine x and the derivative of u is du is equivalent to cosine x dx, then we could write our equation as the integral of u cosine x, where our dx is simply du all over cosine x. Then we could cancel out cosine x here, and the integral of u du is simply u squared 1/2 times u squared, that is 1/2. Then our u is sine, then taking the squared, taking its square, that is 1/2 sine squared x plus c. We could check our answer, and we should be arriving in this format of integral. Now, by checking, we will take the derivative of our final answer, which the derivative of sine x is cosine x plus the derivative of 1/2 sine squared x is simply 1/2 to sine x, and the derivative of sine x using the chain rule method is cosine x, and that is dx is equal to, this will cancel, 2 will cancel out, then taking out the common term here, which is cosine x, then 1 plus sine x dx. If we introduce a multiplier, where if we multiply the whole term with 1 minus sine x all over 1 minus sine x, then this is also equal to cosine x times 1 plus sine x multiplied by 1 minus sine x is 1 minus sine squared x dx all over 1 minus sine x. Now, 1 minus sine squared x is equivalent to cosine squared x. Then, our final answer is cosine cube x all over 1 minus sine x dx. So, our final answer is correct, since if we take the derivative of our answer, is we will get back to our integral function, that is cosine cube x all over 1 minus sine x. As I said earlier on this video, that this kind of integral has 3 solutions on showing your final answer. Now, evaluating the integral, we have the integral of cosine x is sine x plus, on the first method, we let u as the variable, as a function of sine x. Now, in the second method, now if we let u is equivalent to cosine x, then the derivative of u is du is equivalent to negative sine x dx. Then substituting our newly assigned variable, sine x cosine dx is simply our du, which it has a negative. Taking the negative out of our integral, then this is negative u du. Then this is equal to negative 1/2 u squared, where our u is cosine x. Then we could write this one as cosine squared x plus c. Now, our final answer is also equivalent to our previous answer. Now, if we expand this, we already know that the cosine squared x is equivalent to 1 minus sine squared x. So, rewriting our final answer as sine x minus 1/2 multiplied by 1 minus sine squared x plus c. Then, this is sine x minus 1/2. Negative times negative is positive 1/2 sine squared x plus c. Note that the 1/2 here is also a constant. We could write our final answer as equal to sine x plus 1/2 sine squared x plus c. Now, this is true in this final answer. Now, using the third method on showing our solution, we could write the integral of cosine x is sine x plus, we should transform this one into using double angle identities, where this is also equal sine theta plus theta is equivalent to sine theta cosine theta plus sine theta cosine theta, or we could simplify this one as 2 sine theta cosine theta. Notice that in our original function, there is no numerical coefficient of 2 here. Now, imagine that if we will multiply both sides with 1/2, then we could say that 1/2 sine 2 theta is also equivalent to sine theta cosine theta. So we will be using this, our equivalent form of sine x cosine x. So rewriting equivalent form of this integrand, we have 1/2 integral of sine 2x dx. Now, if we let u is equivalent to 2x, then du is equivalent to 2 dx. Then we could write our integral as 1/2 sine u, where our dx equivalent to 1/2 du. Then simplifying, sine x plus, this will become 1/4 integral of sine is negative cosine u, which is 2x plus c. Simplifying our final answer, this will become negative 1/4 cosine 2x plus c. This is also true. Sine x minus 1/4 cosine 2x plus c is also equivalent to our final answer of our first method, sine x plus 1/2 sine x plus c. Now, we could prove that if we are to expand the second term as this one. This is also equal to sine x minus 1/4, we already know that the cosine 2x is also equivalent to 1 minus 2 sine squared x plus c. Distributing 1/4 on each term, that is sine x minus 1/4 plus 1/4 multiplied by 2 is 1/2 sine squared x plus c. Notice that 1/4 and c are constant. We could annotate that one as plus c. Then this is equal to sine x plus 1/2 sine squared x plus c. So we could prove that our final answer here is also equivalent to this one. Now let's take a look on our another example. You can pause this video and answer the question. Now we could evaluate this integral by expressing first the group in the parentheses, and this is equal to the integral of cosine squared x plus 4 sine x cosine x plus 4 sine squared x all over cosine x dx. We need to simplify first before we evaluate each term with integral. So we divide each term with denominator cosine x, that is equal to the integral of cosine x dx. Since factor cosine x will cancel out, and it will remain with cosine x dx plus 4 integral of sine x dx. This is true because we could cancel out the cosine x here. And lastly, the third term is 4 integral of sine squared x all over cosine x dx. Evaluating each integral, we have the integral of cosine x is sine x negative 4 cosine x plus transform the sine squared x to its equivalent trigonometric identity, in which this is also equal to 4 integral of 1 minus cosine squared x all over cosine x dx. Then dividing each term with its denominator, we have 4 integral of 1 over cosine x is secant x and dx, and minus 4 integral of cosine squared x divided by cosine x is cosine x dx. And now our answer is sine x minus 4 cosine x, and the integral of secant x is 4 ln secant x plus tan x minus 4 sine x plus c. Now simplifying the answer, we have 4 ln secant x plus tan x minus 3 sine x. This is true because minus 4 sine x plus sine x is negative 3 sine x, and minus 4 cosine x plus c. And this is our final answer. That will be all, and see you on our next video.